Before we get started, if you haven't subscribed to the channel, please consider subscribing. In this video, we will take a look at how to work with census microdata, and we will, for the purpose of demonstration, we will estimate a labor supply equation using the 2006 Canadian census data. So in order to organize this tutorial, I have taken this problem as a guide so that we can solve each of the different steps and then learn how to work with this large micro data. Okay, so let's go through the different tasks that we have to perform in order to work with the data. So the first task is we have a zipped version of our Stata data file. We can download the data from StatScan's website. We can get the publicly available public use microdata. So the first thing that I will do in the first step is read the data, subset it so that it's a little bit smaller in size, keep it for only Ontario so that again we drop some observations and we are looking at only one province, and then we can from there we'll take it to the analysis stage. Okay, so let's take a look at here. So I have already done these steps. The first step is you change directory and you set a working directory where you have the data. So as you can see, I have already downloaded and I have the individual public use micro file 06 for 2006 census. It's in tabulated format. So I have read the data using import delimited. And then what I have done is I've got the unique identifier in the first column using the order command. And then I've saved the data as 2006 census.tta in my folder. So we can go ahead and run the use 2006 census.tta command. And again, we can go back to Stata window here and we can look at the data browser. And here we can see that we have this large data set with a bunch of different variables to work with. And we have 844,476 observations. Now, one thing we need to keep in mind is that there is a data dictionary that comes along with this data set. And that data dictionary has definitions of each of the different variables, as well as how the different values in these variables are labeled and what they actually mean, or the different categories that are used. So I have already taken a look at that, and I have identified the information that I need for the purposes of this video, so I'll just get right over with it. So the first is I'm going to subset the data for Ontario only. The variable PR refers to province, the variable PR in the dataset. So I'm going to set PR equals to 35 so that I can subset it for Ontario only. So keep if PR equals to 35. We can go back to the data. We can see that 519,503 observations have been dropped. So now we have 324,000 observations. But that's a decent number of observations to work with and to do this tutorial. Next is I am going to subset the data for individuals in the age group 15 to 65 because my objective is to estimate a labor supply equation for the purposes of this demonstration. I'm going to subset the data for people who are in the working age. All right. So keep if age group is greater than or equals to 6 and age group is less than or equals to 17. Again, these are age groups, and we can look into the data dictionary and we'll find that the age group 17 basically refers to folks who are aged 65 or above. So we want to keep below this category and above this category. Next, we subset the data to people who are wage earners and who are not self-employed. So because we want to do a typical labor supply equation, we are going to drop all the people who are self-employed, and we're only going to keep wage earners. And that variable is COW, and 4 is the label or a value label that's assigned for those who are wage earners. So after we do the subsetting, now we have 164,498 observations, still a decent number of observations. Next, we subset the data to avoid observations that are either missing or represent aggregated values for multiple types of individuals. So here we will take the variable hours worked, because that's one of the major variables we'll need for our estimation. And I'm going to drop if hours worked equals to 999 or if hours worked equals to 98. So these are the observations where data has been suppressed or data is missing or data is aggregated. So we drop these and see 0 deleted here and 582 deleted here. All right. Next is data is already subsetted to people in the working age, and we want to drop weeks worked in 2005. So we only want to keep folks who have worked in 2006 in the weeks that the survey has been conducted. So we can do this, and okay, 0 observations deleted. So that's a good check here. And I have a few notes here based on what these different values represent. Again, I've taken this from the data dictionary. So the value 98 represents the average hours of work reported. Who reported 84 hours or more during the reference week. The value 999 stands for not applicable. And then there are different code decodings given for the age groups. And then we can look at the definitions of the variables that we're going to work with. So I'll go forward and I'll move to the next part where we generate the annual hours worked variable. Again, to refresh what we've done so far, we've basically read a large data set, publicly available microdata. We've subsetted it in a way that is helpful for our analysis. And one of the main important things we need to do for the subsetting is understand the data dictionary so that we identify the key variables and what the different categories or the different labels mean in this data set. If you like my videos and find them helpful, then please support my work by subscribing to the channel.